Hello and welcome. MVRP, or the Multiple VLAN Registration Protocol, is going to make the VLAN management process more efficient on your Mikrotik switches by taking care of all the uplink interfaces. Still, the access port will require some manual setup, but all the uplinks, all the tag interfaces or the trunk interfaces can be configured dynamically by this protocol. My name is Wilmer Almazan, and this is the Network Trip. This video is coming in response to a request from one of the subscribers of the channel who was explicitly asking about MVRP. Before jumping into the action and completing the lab, we're going to understand what is exactly MVRP, all the different elements that will be participating, and what's the logic behind this protocol. So MVRP is based on the Multiple Registration Protocol. It's basically a modification of the AO2.1q standard. If you're interested in going deeper with all the technical in and outs of this protocol, you can check the IEEE AO2.1ak amendment. That is basically a modification of the AO2.1q standard. So we'll cover all the general functionality that you need to know to be able to implement this protocol in your layer 2 network with Mikrotik devices. So first of all, we need to identify that we're going to have two components. The first one is going to be the applicant, that is basically a device that is going to be declaring attributes. And the second one is the register, that is basically a device that is going to be taking those attributes that are coming from the applicant and then is going to use that information locally, and also the device can be propagating that information to the rest of devices in that broadcast domain. So in summary, if we are using MVRP, we are going to reduce the manual configuration process. We are going to optimize the traffic because the switches will register the VLANs that they require only. So we're going to see clearly this in action during the lab. How are we going to perform the configuration? So I have specified the steps on this diagram. So first of all, we're going to need the bridge interface on every device, and we are going to add all the ports to that bridge. So remember, if we want to take advantage of hardware offloading, we must add all the ports to a single bridge. We can't have more than one bridge on the same device. Then we're going to configure the management VLAN. We want to isolate the user's traffic from the management traffic. We're going to configure all the access ports, and we're going to disable MVRP on those access ports because we don't want to be sending messages for MVRP where end users will be connected. And finally, we're going to enable VLAN filtering, and we're going to enable MVRP globally. So there are two steps here that I have already completed on my lab. So I have created a bridge on every device, and I have added all the interfaces to that bridge. And additionally, I have the management VLAN, and I have an IP, a default route, and also I have given access to the CPU to that specific VLAN. Now I'm gonna explain how the topology looks like and what is the objective that we have with this activity, and then we're gonna proceed with the actual configuration for MVRP. So I have this on GNS3. So we can see here that we have a switch number 1 that is at the edge of the network, so where we have a connection to internet. So this device is going to be performing inter-VLAN routing. So if you want to use a switch for inter-VLAN routing, the recommendation is to use layer 3 hardware offloading to avoid increasing the CPU usage. So there is a video about that here in the channel. So then we have the switch number 2, we have the switch number 3. Those are pure layer 2 switches. And we can see that each of those switches will have some access ports that will be connected to the VLAN 10 and some access ports that will be connected to the VLAN 20. So at this point, I have completed the step 1 and 2. So basically, I have the bridge created in every device. And also, I have the management VLAN, that is the VLAN 99. And every switch has an IP for management. So this is the .1, .2, and .3, and they belong to the network 10.99.99.x, where x is .1, .2, or .3 respectively. We're going to start with the configuration for the switch number 1. So we check this device, so we have the bridge created, we have all the ports, so in this case port 1, 7, and 8. And additionally, I have created a VLAN interface for the management VLAN, and that one has an IP address, 10.99.99.1. So the step number 3 is about the configuration of the access ports, and we are going to disable MVRP on every interface. According to the diagram, the port Ether8 is an access port for VLAN 10, and the port Ether7 is an access port for VLAN 20. So we simply have to change the per VLAN identifier in those ports. And to do that, we are going to go to bridge and to ports, and then we go to Ether7 to the VLAN tab, and I will set this value to 20. And additionally, I don't want to be sending MVRP messages out of that interface because this is facing end users. So I will go here to the applicant state, and we're going to move this to non-participant. And then we click OK. We're going to do the same for Ether8. The only difference is that this is for VLAN 10. This is an access port for VLAN 10. And also for the applicant state, we're going to set this to non-participant. So basically this means this is not going to be sending MVRP messages. So now we have completed this step, the step number 3. So the next step is to enable VLAN filtering and MVRP globally. So before doing that, we're going to check the VLAN table at this point. The only entry that I have now is the VLAN 99 that is going to be tagged for the bridge. So basically we are allowing access to this VLAN to the CPU, and then we'll be able to manage this device via VLAN 99. So it's exactly the same that we have been doing in all the VLAN filtering configuration that we have covered in another videos here in the channel. So this is what we have now, but we're going to complete the step number 4. So I will go to the bridge interface, and then we go to the VLAN tab. We're going to enable VLAN filtering, and then here at the bottom you can see that we have MVRP. I will simply check that box, and then if I click apply and OK, and I go back to the VLANs table, you can see that these two columns, the current tag and current on tag, have been populated. And we can see the VLAN 10 and 20 that have been dynamically created because we have set the per VLAN identifier on Ether 7 and 8 in the previous step. But we can see that current tag is empty. It's not available on Ether 1. And that is because we haven't performed the configuration in the switch number 2, and that still is not running MVRP. So that's all that we need on the switch number 1. I don't have to configure the trunk interfaces because that is something that MVRP is going to do. Now we have ready the switch number 1, and we'll continue with the next one. So the next switch is the switch number 2. So we're going to follow the same process. So we're simply going to configure the access ports, and then we'll enable VLAN filtering and MVRP. So I will go here. The port 8 is an access port for VLAN 10. So this switch currently only has the bridge interface with all the ports on it. I also have a management interface. There is an IP on that management interface, and there is a default route that is pointing to 10.99.99.1. If I check the routing table, so basically you can see that this is using as a gateway Ether 1 on the switch number 1. So that's all that we have now. So there is nothing related to the VLANs. So the step 3 is to add those access ports. So I will go here to bridge and then to ports, and the port 7 is an access port for the VLAN number 20. And also we are going to say that this is non-participant for MVRP applicant. And then for Ether 8, we're going to set this to 10, and it's also non-participant. So basically the access ports are ready, and the next step is simply to configure VLAN filtering and MVRP. And to the VLAN tab, we'll click on VLAN filtering and also we'll enable MVRP. I would like you to check what is going to happen on the switch 1 after applying the changes. So after applying the changes, what is going to happen is that they will exchange some messages, and now those VLANs 10 and 20 that currently don't have any tag ports will know that they need to be sent as tag traffic out of the interface Ether1. And also that Ether1 of the switch 2 is going to be a trunk interface. So let's see what is going to happen. So I'm going to click apply. And then you can see here that now there is a new entry that basically is telling VLAN 10, 20, and 99 will be sent with tags out of Ether1. And if I go to the switch number 2, so we have something similar. So you can see here we have the VLAN 10, we have the VLAN 20, and they will be sent with tag out of Ether1. So basically, I don't have to configure any trunk interfaces except the one that is for the management VLAN, because here, this is something that we have to manually set. So then the next step is on the switch number 3, and we're going to follow exactly the same process. Okay, so now we are in the switch number 3, and we have exactly the same than the others. So I only have the bridge, and I have all the ports on that bridge. And additionally, I have created the interface VLAN 99 that is hosting an IP 10.99.99.3. And also we have a default route that is pointing to 10.99.99.1. So that's all that we have here. There is nothing about VLANs. So the step number 3 is to configure the access ports. As per the diagram, we have the Ether 7. There is an access port for VLAN 20, and it's non-participant for MVRP. And then we have Ether 8. There is an access port for VLAN 10, and it's a non-participant for MVRP. I have only configured the access ports. If I check the VLAN table, you see that I only have the management VLAN that is going to be tagged on Ether 2 and also on the bridge itself. Nothing else. So now I will simply enable VLAN filtering and MVRP. And basically this is also going to generate those trunk interfaces dynamically. So now I will click OK. And we can see here that the switch number 2 has created this trunk that is telling all the traffic for VLAN 10 and 20 that is going to be sent out of Ether 2 is going to be tagged. And if I go to the switch number 3, I have also this trunk interface that has been created dynamically. So I didn't create any trunk interfaces. That's something that MVRP is performing. And now to test the IP connectivity, I'm going to go to this switch number 1, and I'm going to create the interface VLANs because this is the one that will be performing the inter-VLAN routing. I will simply come to interfaces, and I will create 2 interfaces. VLAN 10 that is going to be on the bridge, and also I will create VLAN 20 that is also going to be on the bridge. And then we're going to set some IPs to the VLAN 10. As per the diagram, this is 10.10.10.1/24. And for VLAN 20, this is going to be 10.20.20.1/24. To make this process simpler, I'm going to create the DHCP server on the VLAN 10, and I'm going to create another DHCP server on the VLAN 20. And I need to give access to the CPU to those 2 VLANs. So I will go to bridge, and then here under VLANs, I will add an entry, and basically for VLAN 10 and VLAN 20, we have to give access to the bridge itself. And now we can click OK. And this is simply going to allow the access of those packets to to the routing process, and this device will be able to perform the task. Now we'll come to PC1 that belongs to the VLAN 10, and we're going to try to get an IP from that DHCP server. So IP DHCP, and we see that the DORA process is working successfully, and we got the IP 10.10.10.254. So we're going to go to PC3, that is on the switch number 2, IP DHCP, and we see that the DORA process is also working. And then PC5, that is also on the VLAN 10, and the DORA process is also working. So now we can try to reach this IP from PC5. So we can simply go ping 10.10.10.254, and we see that we have IP connectivity. The same is going to happen for PC2, PC4, and PC6. So now those PCs on VLAN 20 also have an IP, and we can test the IP connectivity. We see that we have full IP connectivity. We don't have connectivity between the VLANs at layer 2 because we have VLAN filtering, but we have IP connectivity because we have the router that is allowing that communication. So for example, from this PC that is on VLAN 20, I can send traffic to a PC that is on VLAN 10, but this is happening at the router level. So on this switch that is performing inter-VLAN routing. If I want to block the traffic going from one VLAN to the other, I can simply come to the switch number 1 and I can create a firewall rule. Like for example, I can say everything that is coming from the network 10.10.10.0/24 and going to 10.20.20/24 is going to be dropped. And also we can change the direction. And we can say that everything that is coming from the VLAN 20 and going to the VLAN 10 is also going to be dropped. And at this point, if I go to that PC and I send traffic, this traffic is going to be blocked by the firewall. So we don't have any connectivity at the switch level. They are in two separate VLANs, and the switch 2 and 3 are just layer 2 devices. They can't perform routing at this point. The one that is performing the inter-VLAN routing is the switch 1, and then here we can filter the traffic at the IP firewall level. So basically this is how MVRP works. And the magic of this is that if we in the future need to add a new VLAN, so let's say that we want to add another PC here, and that is going to be with VLAN 100. It's going to be on Ether 6. And also here it's going to be on Ether 6. So if those devices will be in VLAN 100, we are simply going to configure switch 1 with the interface VLAN, with the IP, the access port for VLAN 100, and then the access port for the switch number 3. And then all the switches in between will have that information and will allow that VLAN ID on the trunk interfaces. So let's see how that works. So I will go to the switch 1. And I will simply create another VLAN interface for VLAN 100. And this is going to have an IP. The IP is 10.100.100.1/24. And then we need to allow access to the CPU to that VLAN. So we'll go to VLANs, and we can add that here. So it's going to be 100. And then we have Ether 6 as an access port for VLAN 100. So we simply go to the bridge and then ports, and we're going to add the Ether 6. And this is going to be 100, and is non-participant for MVRP. And now this information is going to dynamically be created, but now we only have an access port. There is no tag information for VLAN 100 yet, because we have to configure switch 3, and then the path will be available to send tag frames from switch 1 to switch 3. So I'm going to create a DHCP server as well for this VLAN 100. At this point, this device is basically advertising this VLAN 100, but no one is joining that VLAN, so that's why this device is not going to have a tag port here. But if I check the switch 2, this is receiving the messages, is adding the information as tag on Ether 1, but no one is requesting access to that VLAN. That's why the switch number 1 doesn't have any tag interfaces. And then if I go to the switch number 3, so here we're going to set the Ether 6 as an access port. So I will go to bridge and then ports, and then Ether 6 is going to be an access port for VLAN 100. And it's going to be non-participant for MVRP. So after clicking apply, this is going to request the access to this VLAN. And then we should see this field here populated for VLAN 100. And also we have to see the Ether 2 on the switch 2 as tagged, because we need to send the traffic from switch 2 to switch 3. So we're going to apply the changes, and you can see that now this value has been populated here. And also there is an entry that is going to be created here. So you can see that those VLANs are tagged on Ether 1. So that means that now this PC and the PC7 must have access to the VLAN 100, and they will have IP connectivity. So let's check that. So PC8 got the IP 253 and PC7 254. So let's ping one device. Let's ping from 7 to 8. So we can see that we have full IP connectivity. We only configure the interface VLAN on one switch, an access port in any remote switch, and then all the paths in between is going to allow that VLAN as tag interface. It's important to send these access ports as non-participant for MVRP because we don't want to be sending information out of those untrusted interfaces. Currently, all the information of the VLAN that are required in every switch will be populated in the VLAN table. But what happens if we want to forbid one of those VLANs for being populated in one of the switches or the remaining switches on the chain? So let's go back to the topology and let's see this feature that probably is going to help, that probably can be useful for you. Let's say that for any reason I want to send the VLAN 100 to the switch number 3. So what I can do is that I can go to the switch 2 here on Ether 2. I can forbid that specific VLAN ID. So this is switch 2. I will go to the VLAN table and I can simply add an entry and say for VLAN 100, this MVRP forbidden is going to be set for Ether 2. And then we'll click OK. So you'll see that this entry is going to disappear in a few seconds. And now that VLAN 100 won't be sent to this switch number 3. And we can validate that by going to the terminal and we're going to try to send a ping to the PC8. And you see that this no longer works because that VLAN is being removed on the switch number 2. So now I will remove this entry that is going to be sent again. And if I go back to the terminal, so we have IP connectivity. So this is how you can basically filter the information via MVRP. And before finishing the video, we're going to go to the terminal and we'll check what the status of one of the ports in that bridge. And to do that, we can use this command, interface bridge port monitor, and then inside square brackets, find interface and the name of the interface. So I'm going to check Ether 1 on this switch number 1. So if I press enter, we're going to see this declare VLAN IDs. So basically, this is the information that we have manually added into the device. So we can see here that we have VLAN 1, 10, 20, and 100. So those are the values that are static here. And additionally, we have the registered VLAN IDs. And you can see that here we have 99, but we don't have this under the declare. And that is because for VLAN 99, when we added manually that entry into the VLAN table, I didn't specify Ether 1 as a trunk interface. But then via MVRP, that information is required in the other switches, and this switch has registered that port because that has been requested by the other devices. I hope that this video has been informative for you. And please let me know, what do you think about MVRP? Have you used this protocol before? Are you planning on testing this on the lab? If you would like to see a particular topic here in the channel, just let me know in the comments. And remember to get subscribed and enable the notifications. Thank you, and I see you in the next one.